Very good afternoon, everybody, and welcome to this latest edition of our Precision Nanosystems Tea Time webinar series. It's my pleasure this afternoon to introduce our speaker, Dr. Laurence Poul. Laurence is a senior team manager at Curadigm. She has a very strong background in nanomedicine, has a doctorate from Pierre and Marie Curie University in Paris, and has had a strong focus on nanomedicine throughout her career, having joined Nanobiotics in 2007. And she's also been heavily involved in the incorporation of Curadigm, which spun out from Nanobiotics in 2019, and has been involved in the design of the Nanoprimer concept. Hence the title of her talk today, A Nanoprimer to Improve the Systemic Delivery of Various Therapeutic Agents. So while we're here as well, I'd just like to introduce your Precision Nanosystems Europe team as well. We're all very grateful for you for joining us on this webinar today. I'm Richard, and as you can probably guess from my Zoom background, I'm based in Oxford in the UK, and I'm field application scientist covering Scandinavia, Benelux, the UK and Ireland. And as field application scientist, my remit is to cover technical applications and scientific related matters to all interested in using the Precision Nanosystems technology. I'm also joined by AJ in the north of Europe as well. AJ is our commercial lead, and he looks after all sales and commercial related matters in the north of Europe. Based in Berlin, covering Central and Southern Europe, also my colleagues Jürgen and Martin. Jürgen is regional sales manager, and again he looks after the commercial and sales side, and my counterpart, Central and Southern Europe, also based near Berlin in Germany, is Martin Rabel. And thanks again for joining us on our webinar this afternoon. So now it's just my pleasure to hand over to Laurence, and thank you, Laurence, for speaking, and over to you.
Thank you, Richard, for the introduction. Hello, everybody, and thank you, Jane and Martin, for the organization and for inviting me to present our platform. As you know, most of nanomedicines and thus most of the therapeutic agents that are brought with nanomedicine, when injected IV, are trapped at the liver, as illustrated here, where we injected a fluorescent model nanomedicine in a mouse. This results in limited efficacy and liver toxicity, and also to a large part of the product that is useless. And that is due to the mononuclear phagocytic system, MPS, which is one of the main biological barriers of our body. And it is responsible of the hepatic clearance. That is to say, is responsible for hepatic trapping and for further low bioavailability. This results in poor treatment outcomes and potential toxicity or side effects. Various approaches to avoid this problem have been proposed. Those methods usually modify the therapeutic agent or may bring toxicities. That's why here we propose to prime the body to receive the treatment with another technique. We do that by dividing the biological functions into two separate objects. In one hand, the nanoprimer that will handle the bioavailability profile, and on the other hand, the therapeutic agent unmodified. The nanoprimer is designed specifically to occupy the liver clearance pathway, that is to say the Kupffer cells, resident macrophage of the liver, and the LSEC, the endothelial liver cells, all that in a reversible manner. That's why it should be made of biodegradable material. Overall, that way we redefine treatments administration. So how it works. First, the nanoprimer is injected. It occupies the therapeutic liver clearance pathways and accumulate in the liver. Secondly, the therapeutic is injected and the Kupffer cells and LSEC are too busy to stop it. It thus circulates longer, which results in increased therapeutic accumulation at the target tissue. This is illustrated here with the same nanomedicine, the model nanomedicine, when the nanoprimer is injected 10 minutes before. The timing between the two injections of 10 minutes should be adapted to human. It won't be maybe the same timing because we have to take into account the use at the hospital, especially regarding therapeutic session duration. Our platform can be seen in two ways. In most cases, we want to increase the efficacy. So that's directly, you increase efficacy with a nanoprimer. But sometimes what is limiting is the toxicity of your product. In that case, you can lower the therapeutic dose, keeping the same efficacy, and thus reduce toxicity. And what is great with the nanoprimer is that it's universal and it can be combined with a wide variety of nanomedicines associated or not with a wide variety of therapeutic agents. So the nanoprimer in itself is the result of a very precise design based on the requirements I already talked about. It should be biodegradable. That's why we chose liposomes. It should be able to interact with the specific receptors on the Kupffer cells and LSEC. This defined the specific lipid composition of our product. And since we don't want any interaction with hepatocytes, the size should be larger than the disk space fenestra. And this led us to decide a size above 250 nanometers. Until now, we prepare it at the lab scale by film hydration, followed by extrusion. That way, we obtain a first prototype, which allowed us to perform multiple proof of concepts. So we think, as you maybe can see on the cryo-time picture on the slide, we think that we could maybe improve the homogeneity and decrease size distribution. And since microfluidic mixing is widely used for liposome formulation, we decided to investigate it for our nanoprimer preparation. For that, we used the nanoassembler benchtop from Precision Nanosystems, and we succeed to obtain liposomes with our specific lipid formulation and a size around 250 nanometers. Until now, the solution obtained by microfluidic is comparable, equivalent to the suspension we obtained by extrusion in terms of the size distribution. But we have ongoing discussions with Precision Nanosystems to evaluate the possibility of reducing this size distribution. So then we wanted to show the efficacy of our nanoprimer, and to start, we performed an internal proof of concept with a chemotherapeutic nanomedicine, Onivide, which is a suspension of liposomes encapsulating irinotecan. As shown on the slide, we can see that the nanoprimer increased the nanomedicine efficacy when injected 10 minutes before, in a manner that it was equivalent to a 50% increased dose of the nanomedicine. And this was associated with an increase of overall survival. For the second step, we decided to study RNA-based treatments that are also limited by their biodistribution. Indeed, despite huge therapeutic potential, very few RNA-based treatments have been accepted by FDA yet. So for that proof of concept, we initiated an academic collaboration with Professor Langer's lab at MIT on the delivery of RNA encapsulated in lipid nanoparticles. They worked with two different RNAs, a messenger RNA coding for human erythropoietin and a silencing RNA decreasing blood clotting factor 7. As we can see on the slide, with fluorescent RNAs, the impact of the nanoprimer on the distribution was evaluative, and they showed that a 40% decrease of fluorescence in the liver was observed for both RNAs when the nanoprimer was injected before, which was associated with an increase in blood bioavailability between 8 to 16 times. Secondly, they showed that the combination of with the nanoprimer allowed to improve transfection efficacy too. Human EPO secretion was increased by 32%, and factor 7 silencing efficacy raised by 50%. These results were published this year in Nanoletters. Then we wanted to evaluate toxicity profile. Indeed, since we claim to reduce toxicity, we cannot afford to bring some with our nanoprimer. So we checked in vitro on relevant cell lines that there was no cytotoxicity. We also checked that the nanoprimer had no hemolytic power on rabbit blood. And to anticipate potential immunotoxicity, we checked that the complement activation on human plasma did not occur. And that was, this evaluation was performed by quantifying complement components, C5a and SC5b9. Then we performed a subacute toxicity study on the nanoprimer alone at the therapeutic dose and at a maximized dose 24 hours, and 7 days after injection. During this study, no major changes in body weight were seen. Even if a transient increase of the spleen weight occurred, it returned back to normal on day 7. We also performed blood parameters and histological analysis with the same doses and schedules. No changes in the major hepatic enzymes or kidney parameters were observed, nor significant changes in histological observations. A mild reversible increase in macrophages populations was observed, which was not associated with toxicity, according to the experts we consulted. Because we don't want to put the patient at risk by impeding its immune system, we evaluated if the nanoprimer could induce cytokine storm when injected in human by quantifying the expression of the major pro-inflammatory cytokines 24 hours after its injection. And the obtained cytokine expression was corresponding to the classic profile expected for lipid-based nanomaterial administration. Furthermore, we showed that the nanoprimer does not cause any cytokine-mediated immune response. Indeed, no expression of type 1 and 2 interferon and moderate expression of IL-6 and IL-10 were observed with the nanoprimer. Here is the good slides. The Nanoprimer is a platform. It's able to improve biodistribution profile of a large panel of therapeutic agents. As shown earlier, we already have proof of concept for small molecules, for RNAs, and the evaluation of the combination with virus and genome editing nanomedicines is ongoing. Nowadays, we have various partnering in different therapeutic areas, and the combination are also under evaluation, and it can go from rare disease, central nervous system disease, oncology, and RNA, DNA-based therapeutics. So it was to develop this platform that Curadigm was incorporated a year ago. And we are a subsidiary of Nanobiotics, which brings us great support in terms of science and finance. And we are 8 employees. And thank you for your attention. We are ready for questions.
Then it's time to close. So thanks a lot for your availability here, answering all these questions, giving this presentation. Best of luck and success with your technology going forward. And I thank everyone for joining today. And we hope to see you again in 2 weeks where we have our next Tea Time webinar. So stay tuned. Thank you too. And bye-bye, everyone.
Bye-bye.